Today we're going to continue talking about finding integrals algebraically. We're going to practice the rules that we learned on Thursday night and Friday in class, and this time we're going to apply those rules to finding definite integrals by hand. So just as a reminder of the rules that we know so far, we know that the antiderivative of a constant function is linear, so kx, don't forget the plus c if it's an indefinite integral. We know that the antiderivative of a power function, we're going in reverse, so if we're finding the integral, we add 1 to the power and divide by the new power. We know that the antiderivative of e to a power is e to the power divided by the derivative of the power. We know that the antiderivative of sine x is negative cosine x. The derivative of cosine is negative sine, so the integral of sine is negative cosine. Know that the antiderivative of cosine x is sine x. We know the antiderivative of 1 over x, or x to the negative 1, is natural log x. We know the antiderivative of tangent x secant x is secant x. And we know the antiderivative of secant squared x is tangent x. So those are the rules that we learned. And then also remember we have two operational rules. We know that if we're finding the integral of a coefficient times a function, then the coefficient is just going to come along, just like it does in a derivative situation. And we know that if we're finding the integral of two functions added or subtracted, then we can just find the antiderivative of each and add or subtract as they were in the initial relationship. Okay, so today we're going to move into finding definite integrals. These are all indefinite because I'm starting with a function and getting a functional answer. Looking at finding definite integrals, remember what we know about the fundamental theorem of calculus, that if I have the definite integral of a derivative, then that definite integral is the change in y values on the original function. So it's the antiderivative function evaluated at b minus the antiderivative function evaluated at a. Notice that when we write this, we're doing larger minus smaller. Normally when we put it in the calculator, we put in a first. When we write it, we write a first. But when we're evaluating by hand, we're going to do f of the larger minus f of the smaller. So really thinking of right minus left. So now we can find the exact value of definite integrals. Since we actually have the two pieces now, we know how to integrate from f prime back to f. And we know the definition of a definite integral is f of b minus f of a. Let's look at some examples. So here are some examples for us. The first thing that we're going to do is find the antiderivative like we were doing yesterday in yesterday's notes, or in Thursday's notes. That'll be yesterday. So we're going to integrate from 1 to 3. This one I need to rewrite to as a power function, r to the negative 3 dr. I'm going to integrate first. The 2 will come along. Add 1 to the power. Divide by the new power. We'll talk about, I'm going to go ahead and write plus c. We'll talk about what happens to the c in this setting. So my indefinite integral, or my antiderivative function, turns out to be negative r to the negative 2 plus c. Then, so this is my f. Now I need to find f of b minus f of a. The way I'm going to write that, now that I've actually performed the operation, that is the integration part of it, I've found the antiderivative, I need to keep up with my left and right endpoints in my A and my B. So I'm just going to stick those here. This line means evaluated at, the line there. Evaluated at 1 and 3. I remember that I'm going to evaluate f of b, so f of 3. Minus f of a, so f of 1. Notice the parentheses and the big minus in the middle. I think that's easier so that you don't get lost with negative signs. So here's f of b is negative 3 to the negative 2 plus c. Here's f of a. So I'm subtracting f of b minus f of a. I need to do a little algebra or a little calculator work here. I remember that 3 to the negative 2, we'll move this problem over there and do that one in a minute, that 3 to the negative 2 is negative 1/9 plus c minus negative 1 to the negative 2 is 1 plus c, negative 1 plus c. And notice what happens with the plus c's. I have a plus c here minus that plus c there. So those go away. And that always happens. So when I'm doing a definite integral, I don't actually have to include the plus c. So negative 1/9 minus negative 1 is the same as negative 1/9 plus 1. And so 8/9 is the value of my definite integral. And you can check that with Math 9 on your calculator. We've been able to do that for some time. So you can use Math 9 and evaluate. And just remember, when you put it in your calculator, unlike when you do it by hand, you put in a comma b, so 1 comma 3. When you're doing it by hand, you're doing f of b minus f of a. So you plug in the 3 first and then the 1. And again, notice that the 2 plus c's cancel, and they always will. So when I do this next example, because it's a definite integral, I'm not going to include the plus c. So if I integrate this, the 2 comes along. The integral of e to the x is just e to the x. That now is this was my derivative function. This is my original function. I'm going to evaluate that at negative 1 and 1. Again, remember, just that long bar means evaluated at, so it allows me to carry my a and b over. Then I know from the fundamental theorem of calculus I need to do f of b minus f of a. This would probably be a non-calculator problem, so I would probably end up with just this as my answer. And I would leave it there. No need to evaluate out to a decimal. Okay, let's do question 3. Let's make sure we have some space here, since question 1 kind of ran over. So we can do question 3. Again, this is just a direct antiderivative. The antiderivative of secant squared is tangent, because the derivative of tangent is secant squared. Evaluated at 0 and pi over 6. I don't have to have the plus c's because they would just cancel out anyway. When I find the antiderivative function, so when I take secant squared back to its original, the underderivative, then I lose the integration sign because I've done that operation. And then my evaluated at here and my a and my b. And my rule is, so this was f prime here, this is f here. So the fundamental theorem of calculus says that that value is f, so this guy, f of b, tangent of pi over 6, minus f of a, tangent of 0. It's unlikely that I have learned that I've learned the unit circle values for tangent, so I need to think of tangent as sine over cosine. So I'm going to come over here and do that. So sine of pi over 6 divided by cosine of pi over 6 minus sine of 0 divided by cosine of 0. And sine of pi over 6 is 1/2. Cosine of pi over 6 is the square root of 3 over 2 minus sine of 0 is 0. Cosine of 0 is 1, but that's just 0. 1/2 divided by the square root of 3 over 2 is the same as 1/2 times 2 divided by square root 3. And my answer is 1 divided by square root 3. And again, I'm just going to leave it that way, no decimals, because it would probably be a non-calculator problem. We can also do application problems now by hand. So here is an example of an application problem that we can answer algebraically without the calculator. This is our familiar context of here's velocity given by it. S of t represents position. So here's my derivative function. Here's my original function. At the particle at time t, and S of 0 is 5, so there's an initial condition. Find the position function for the particle. And notice that I'm being asked to find the position function, so I need an indefinite integral. So I'm going to integrate 2 plus e to the 2x dx. I'm integrating the derivative to go back to the original. This is an indefinite integral. It didn't ask me to do it over any particular time interval. So integrating those separately, the integral of 2 would come along, x plus e to the 2x, e to the kx is e to the kx times 1 over k, or e to the power divided by the derivative of the power. This time I have my plus c, because that's not a definite integral, it's an indefinite integral. But I can find c because I have this initial condition. I know that S of 0 is 5. So I know that this is my, I should have called it t, no x. I should have called it, okay, so this is my S of x, call that. And so S of 0 is 5, so 5 is 2 times 0 plus 1/2 e to the 0 plus c. 2 times 0 is 0. E to the 0 is 1, so 1/2 plus c is 5. So c is 4.5, 4.5. And I can find my final function of x is 2x plus 1/2 e to the 2x plus 4.5, or 9/2 if you like that better. And there's my position function. And I could then evaluate that position function at any time I wanted. So I could plug in 3 or 5 or 7 or 11, and this function would tell me what the position was at any of those time values. Okay, and our last example here of another thing that we can now do by hand that we used to use the calculator for. This question is asking me for average value of f of x. You'll remember, I hope, that that's the 1 over b minus a formula. So this is my formula. The integral from a to b of f of x dx. So if I plug in what's been given to me in this problem, I have a and b, here's a, here's b. So I have 1 over e minus 1, the integral from 1 to e. And I'm going to rewrite that f of x because it's a quotient and I don't have quotient rule for integrals, and so I'm going to write it as x to the negative 1, 1 plus 2x plus x squared. And then I remember I also don't have a product rule for integrals, and so I'm going to have to distribute that x to the negative 1. I'm adding exponents. X to the negative 1 times 1 is just x to the negative 1, plus x to the negative 1 times 2x is 2, x to the 0, right? So that's just 2, plus x to the negative 1 and x squared. Adding exponents would give me just x to the first. 2 plus negative 1 is 1. Dx. I still have my 1 over e minus 1 out here. Now I'm going to deal with what's on the inside. So now I'm actually going to integrate or find the antiderivative. So x to the negative 1, if I add 1 to the power and divide by the new power, I get x to the 0 over 0. This is my alarm bell. So I know if I get x to the 0 over 0, that should be natural log x, plus the integral of 2 is 2x, plus x squared, add 1 to the power, divide by the new power. I want all of those evaluated at 1 and e. Still going to leave this guy out front. Haven't done anything at all with him yet. I'm just going to leave him hanging out there. Now I'm going to plug in, this is f. Here's b, here's a, so I'm going to plug in f of b. The natural log of e plus 2e plus 1/2 e squared minus, and I'm going to plug in 1, the natural log of 1 plus 2 plus 1/2. And if I do some calculation there, I'm going to kind of go up to the upper right-hand part of the screen there. And so I still have 1 over e minus 1 hanging out here, times. The natural log of e is 1, plus 2e, and then plus 1/2 e squared, minus, the natural log of 1 is 0, and 2 plus 1/2 is 5/2. Still have 1 over e minus 1 out there. 1 minus 5/2 gives me negative 3/2 plus 2e plus 1/2 e squared. I could distribute the 1 over e minus 1, but I think I'll just leave it in this format. If I wanted to get a final answer here, a decimal approximation, I would need the calculator because I'm not going to be able to estimate e minus 1 and e squared very well on my own. But just notice that we can now do average value. We can use that formula. The algebra is a little, and the arithmetic's a little challenging, but we can do that now. Okay, that's all for today. See you in the video quiz.